500 years before the first cable machine was bolted to a gym floor, Persian warriors were developing grip strength that modern athletes spend entire training careers chasing and never fully reaching. Not because they had better technology, because they had a complete system. The zircana, the House of Strength, has operated continuously in Iran since at least the 10th century CE. The training that took place inside those octagonal pits was not random physical labor. It was a codified system of movements, performed in sequence, designed to build specific physical capacities from the ground up. And grip was not one item on a checklist. It was the thread running through every single movement. Here is what the modern gym replaced that system with: a machine with a padded handle, a cable, and a stack of numbered plates. You sit down, you squeeze, you stand up. The zirconieh athletes who trained 7 days a week across decades of competition did not produce the kind of grip that comes from a machine. They produced something a machine cannot replicate, because a machine trains one direction of one motion, and the Persian system trained grip as a total body expression of force. This video covers the 5 movements that produced that result, exactly how they worked, and how to apply them now. Before we get to the movements, you need to understand what your current approach is actually building, and what it is quietly leaving behind. The problem with how modern gyms train grip. The mainstream grip training model has one answer for everything: load the fingers and squeeze harder. Wrist curls, reverse wrist curls, the grip machine, a thick-handled dumbbell if the trainer is feeling adventurous. Every tool, every exercise, every protocol operates on the same assumption, that grip is a localized capacity, produced by the forearm flexors, measurable by how hard you can close your hand. That assumption is not entirely wrong, but it is incomplete in a specific and costly way. Grip strength in functional terms, the kind that transfers to lifting, carrying, climbing, fighting, and resisting fatigue across decades, is not generated by the forearm alone. It requires coordinated tension from the wrist extensors, the intrinsic hand muscles, the rotator muscles of the forearm, and critically, the stabilizing chain that runs from the fingers through the elbow to the shoulder girdle. When grip fails in real situations, it rarely fails because the fingers ran out of force. It fails because the supporting chain, the wrist, the elbow, the shoulder, lost tension before the fingers did. The machine trained the fingers. The chain trained itself. Which is to say, the chain did not train at all. The zircana system did not have this problem, because it never separated grip from the structure surrounding it. Every movement in the Persian system trained grip as an output of total body tension. The 5 movements below are the ones that built that capacity. And the reason each one works is the same reason your grip machine does not. The body does not operate in isolation, and the ancient system never pretended that it did. Movement 1, the meel, Persian clubs. In the zircana, the meel is a wooden club shaped like a bowling pin, ranging from a few pounds for beginners to over 40 pounds for advanced practitioners. Pairs of meels are swung in coordinated circular patterns, behind the head, across the body, overhead, while the practitioner stands in place and maintains posture through each arc. What makes the meel the foundation of this system is what it demands from the grip throughout the movement, not just at peak load. When you hold a barbell, the weight is centered in your palm. The load is symmetrical. The wrist is in a fixed position. When you hold a meel, the weight is offset. The mass sits at the end of a long lever, constantly shifting the demand on your grip as the club moves through its arc. At the top of the swing, you are resisting extension. At the bottom, you are controlling flexion. In the lateral arc, you are resisting supination or pronation, depending on which direction the club is traveling. The mechanism here is called variable load grip training. The muscles of the forearm, the flexors, extensors, and rotators, are forced to fire in rapid, coordinated sequence rather than in a single, sustained contraction. This produces the kind of grip endurance that persists across long durations and changing demands. To apply this now, start with a single light club or a heavy-headed hammer between 2 and 4 pounds. Perform 10 to 15 circular swings per arm, focusing on keeping the wrist neutral at the top of the arc. The self-test is simple. If your wrist breaks outward at the top of the swing, the club is too heavy. Progress when the wrist stays locked through 30 consecutive swings per side without deviation. Movement 2. The sang, chest press with weighted shields. The sang is a wooden shield-shaped board, weighted with lead or iron plates, pressed overhead or swung out to the sides from a lying position on the zirconium floor. Think of it as the ancestor of the chest press, but the resemblance ends at the basic motion, where a barbell bench press concentrates load at two symmetrical points along a fixed bar. The sang requires the practitioner to control a flat, wide object. The fingers cannot wrap around a narrow handle. They splay across a broad surface and grip it by compression and friction, what grip scientists now call a palmar grip, as opposed to the digital grip your cable machine trains. This distinction matters because palmar grip activates the intrinsic muscles of the hand, the lumbricals and interossei, in ways that digital grip does not. These are the muscles responsible for the firmness and density of the hand's architecture. They are also the muscles most neglected by every machine in a commercial gym. The practical replication. Use a flat-bottomed object, a heavy book, a weighted plate held flat between both palms, or a sandbag pressed against the chest with splayed fingers. Press it overhead 20 times while focusing on pressing through the entire palm, not gripping with the fingers. The goal is to feel the center of the hand, the pad below the middle finger, working as hard as the fingers themselves. This is the part of grip your gym has never addressed, which is why your handshake is firm but your hand fatigues when the load spreads out. Movement 3. The kabbadeh, the iron bow. This is the movement that separates the zirconium system from every other grip training tradition in recorded history. The kabbadeh is a large iron bow, not a weapon but a training tool, with a thick, rigid arc and a central grip. The practitioner holds the grip with one hand and draws the bow open against the resistance of the arc, extending the arm while the steel resists. Unlike an actual bow, which is released, the kabbadeh is drawn and then returned under control, never allowing the spring to snap back. The mechanism is eccentric loading of the wrist extensors, the muscles on the back of the forearm that most grip training ignores entirely. Wrist flexor strength without corresponding wrist extensor strength creates a muscular imbalance that loads the lateral epicondyle, which is the bony point on the outside of your elbow. That imbalance, accumulated over years of flexor-dominant training, is the most common cause of what is typically diagnosed as tennis elbow in men who have never played tennis. The kabbadeh trained both sides of the forearm in the same movement, under the same load, at the same time. That is not an accident of equipment. It is a design principle. To replicate this now, use a resistance band anchored at shoulder height. Grip the band with your palm facing down. Pull the band toward you by extending the wrist backward, not by curling the arm. Hold the extended position for 2 seconds. Return under full control. 10 repetitions per side, 3 times, with a band that makes the last 3 reps difficult without breaking the wrist position. If you have been dealing with nagging elbow pain that appears after heavy pulling sessions, this is the movement you have been missing. Movement 4. The charkh, the spinning plank. The charkh, the Persian word for wheel or rotation, is performed lying face up on the zirconium floor. The practitioner holds a weighted plank or bar across the chest, then rotates the torso in a full lateral spin, keeping the object controlled throughout the roll. The grip demand in the charkh is not about peak force. It is about maintaining grip tension while the body's position relative to gravity is constantly changing, what modern sports science calls positional grip stability. When your body rotates and your arm changes position, the load on your grip shifts in every direction simultaneously. The forearm must not only grip the object, but reorient its internal tension to match the new vector of the load with each degree of rotation. This is the grip demand of climbing, wrestling, and carrying. And it is completely absent from machines because machines fix the body's position and allow only the hand and arm to move. The modern replication, a Turkish get-up with a light kettlebell or a full water bottle, trains a simplified version of this demand. The weight is held overhead as the body moves through 5 distinct positional transitions: floor to elbow, elbow to hand to knee to standing, and back. The grip is not allowed to change its position on the handle throughout the sequence. 3 repetitions per side, performed slowly. If the wrist rotates to compensate for any transition, the load is too heavy. The charkh is where grip training becomes a full-body discipline. This is the movement that answers the question modern fitness cannot. How did Persian warriors maintain grip strength under combat conditions, where the body and the load were both moving at the same time? Movement 5. The dow-al-zeqal, the two-handed mace rotation. The dow-al-zeqal is the most demanding grip exercise in the zurkana system, and the one with the least modern equivalent. A long-handled mace, similar in shape to the Indian gada, is held with both hands and rotated in a full circular arc behind the head, overhead, and back around to the front. The weight of the mace head, sitting at the end of a long handle, creates an extreme offset load. At the lowest point of the arc, behind the head, the forearms are fully supinated, and the grip is resisting the full weight of the mace head falling away from the body. At the highest point of the arc, overhead, the load shifts, and the wrists must transition from supination to pronation while maintaining grip without adjusting hand position. This trains what no machine can produce: continuous grip adaptation under a load that is always changing direction. The mechanism is what exercise physiologists now call dynamic grip endurance, the capacity of the grip to produce coordinated force across multiple movement vectors without recovery time between them. Most grip training produces static grip strength, which is the maximum force you can generate in a single fixed position. Dynamic grip endurance is what carries that strength into the real world. The accessible replication. Hold a heavy dumbbell by one end, gripping the head rather than the handle, with both hands. Perform slow, controlled overhead circles. Up one side, across overhead, down the other side, across in front. Start with a 5-pound dumbbell and 5 circles per direction. The self-test is whether your grip migrates toward the fingers, away from the palm, during the arc. If it does, the weight is too high. The grip should feel rooted in the palm throughout every degree of the rotation. How these 5 movements work as a system. This is the point the list format does not show you on its own. These 5 movements are not interchangeable. They are not 5 variations of the same stimulus. They form a complete system because each one targets a different dimension of grip capacity that the others do not. The meel builds variable load grip endurance across changing forearm positions. The sang develops palmar grip and the intrinsic hand musculature. The kabbadeh corrects the extensor-flexor imbalance that accumulates from every other form of grip training. The charkh trains positional stability, grip that holds under a body in motion. The dow-al-zeqal builds dynamic grip endurance across continuous directional change. Remove any one of these and the system has a gap. Add a machine in its place and the gap remains, because the machine collapses 3-dimensional demand into one direction and calls it equivalent. Zurkana athletes who trained this system consistently did not have the kind of grip that a dynamometer measures well and a climbing wall exposes. They had grip that held under everything, because the system that built it was designed for everything. A modern zurkana grip protocol, using the replications above, looks like this. Meel swings 20 per side, sang press 20 repetitions, kabbadeh pull 10 per side, charkh get up 3 per side, dow-al-zeqal circles 5 per direction. Performed in sequence, once through, 3 days per week. Expect to feel the difference in 6 weeks. Expect to understand what was missing in 6 sessions. The supplement industry cannot sell you this. The machine manufacturer cannot build you this. The Persian system did not need either of them because it was already complete. Intensity built them. Precision kept them. The 5 movements above are where precision begins.